And here's what we were looking at. We went through everything on this page. So we talked about all of this stuff. These are all the details about a hyperbola that we'd need to keep track of. By far, they are the most complicated conic section, but they are pretty cool, and you can actually graph them pretty easily if you think of them as an ellipse that opens out. The only extra thing that we need to keep track of is we do have to come up with equations for the asymptotes, but I showed you a quick, easy way to do those as well. So we graphed these two. So we graphed four hyperbolas all together yesterday, and I asked you to take a look at this one right here and figure that one out. So I've got a nice big graph, plenty of room and stuff like that. Here's what I would do. Okay, if you have this done and you got it right, great. Just make sure that all of this, everything that I say here just kind of confirms what you know. Here's what I would do first. I would figure out what the equation for the asymptotes are. Okay, asymptotes are always in this form. Y minus k equals plus or minus some slope and then x minus h. If you have it in this nice graph-friendly form, you already have the expression y minus k. It's right here. You already have the expression x minus h. It's right here. So we're going to write the asymptotes right now before we do anything else, because that's what people struggle with the most, but it should be the easiest if you've already got it in a graph-friendly form. So this is going to be y plus 1 equals, okay, then I'm going to write the x minus 2, and then I'm going to figure out what number this is. Okay, rise, is that right or left or up or down? Up and down, right? So which variable do we look underneath? The y. Okay, y is up and down. That's going to have to do with the rise. Look underneath here. Square root is 3. Okay? Run is right or left. That's going to be found underneath the x. Look underneath there. It's a 7, square root of 7. Put that right there. That's it. Now that's ugly, but that's what it is. Any questions? Okay, now just a quick word. You may have noticed that when you were graphing an ellipse, and maybe when we were doing these, you kind of have a choice. You can either make the A and the B work out to be nice numbers, or you can make the C, the distance from the center to the focus, work out nicely. So this looks pretty ugly, but it's actually going to turn out to be fairly easy to graph. So here's what we've got. Where is the center on this graph? Okay, make sure you find the X. That's a 2. Make sure you find the Y. That's a negative 1. So we're at 2, negative 1. There's the center. How far are we going to go in the x direction? Square root of 7. So in between 2 and 3. So I'm going to go 1, 2. There would be 3. There would be 2 somewhere in between here. So I'll put a little point there. 1, 2, about right there. In the y direction? 3. 1, 2, 3. So we're right here. And 1, 2, 3. So we're right there. And then we're going to draw the fundamental rectangle. It's not part of the graph, but it'll help us get the right shape. So let me make this smaller. So I'm going to draw the asymptote in here. Asymptote in here. Let's see, opens. How do you tell which way it opens again, John?
It's the variable that's positive.
The variable that's positive. The x is positive, so it opens in the x direction. It's positive, so it opens in the x direction. X is right and left, so it's going to open to the right here. We're going to have a branch over on this side and then a branch over here. So we can now go ahead and draw this. So I'm going to grab a nice big fat line, and I'm going to run along here. It touches the fundamental rectangle right there. Continues to bend around and then straightens out and runs along there. So it's going to hit this point right here. Run along here. Run along here. There we go. Okay, so again, the cool part is we've already got the asymptote figured out. We've got the center figured out. Let's label these points right here. Let's label this one right here. So that is a vertex. And that's a vertex. Let's come up with an equation for these. Remember, this center here is at 2 comma negative 1. And there's an axis that runs across here. Okay, I'll just draw this in lightly. Okay, that has a name. It's called the, because it cuts across them, it transverses them. It's called the transverse axis. Okay, so this point, that vertex, the center and that vertex, they're all on the same horizontal line. So they all have the same y coordinate. The y coordinate would be negative 1. So that's a negative 1, and that's a negative 1. Now, we were at 2, and we went forward, how far? Square root of 7. So this is going to be 2 plus radical 7. We were at 2, and then we backed up that same amount, so this is going to be 2 minus radical 7. Now, I've got the asymptotes figured out. I've got the graph of the actual hyperbola. It's on there. We've labeled the vertices, all that sort of stuff. What's the last thing we need to do here? Find the foci. Okay, now to find the foci, we take these two numbers and do we subtract them or add them? We add them. Can somebody remind us the reason why we have to add them? Yeah, Josh. Okay, if we subtracted, the foci would be inside the box. Okay, we don't want that. Okay, we want them outside the box to guarantee it's going to be inside the curved part of the conic section. So I'm going to take 7 and 9, add those together. That's 16 equals c squared. So c equals 4. So from here I go 4 units. There's a focus. I go 4 units. There's a focus. And then I just label the two of those. So that focus is, well, they're all going to have a y coordinate of negative 1. And I was at 2 and I went forward 4. So that's going to put me at 6. And I was at 2, I went back 4, that's going to put me at negative 2. Okay? If you've got all of that stuff labeled, and I agree, bit of a mess, lots of stuff floating around here. We've got a center that's not even part of the hyperbola. We've got that rectangle that we've drawn, not part of the hyperbola. We've got the asymptotes, not part of the hyperbola, but all of those help us get the right graph and help us label the points. Raise your hand if you did that on your own and got it right. Okay, about a fourth of you. Okay, raise your hand if you did it on your own and got most of it right. Okay, that's a little better. Okay, not bad for only the 5th hyperbola we've graphed. Okay, any questions? We're good? Sure? Okay, then what's wrong with the next two? They're not in graph-friendly form, so we've got to put them in graph-friendly form. That means we've got to have a perfect square with x, a perfect square with y, and we have to make it equal 1 on the other side. So let's go ahead and do this one right here. This one that's pretty close, isn't it? Because all I have to do on that one is just do what? Divide by 4, divide by 4, divide by 4. So this is going to be y squared over 4 minus x squared. I'm going to put the 1 down there, and that equals 1. So where's the center?
0, 0.
Center is at 0, 0. Okay, underneath the y is a 4, so how far do we go in the y direction? We go 2. So we're going to go up to 2 and down to negative 2. How far do we go in the x direction? 1. Okay, so here's the fundamental rectangle. Here are the asymptotes. We'll draw those in. Okay, now I'm going to write the equation for the asymptotes. They go through the origin, so this is going to be y equals some number times x. All we need to know is what the slope is. The y-intercept is 0. We just need to know the slope. We went up 2 and over 1. So this is going to be plus or minus 2. There's the equation for the asymptotes. Again, could we get that by looking at the equation? Yeah, here's the y minus k, it's just a y. Here's the x minus h, it's just an x. Here's the number underneath the y, we take the square root of that, that's 2, that would be the rise. The number underneath the x, take the square root, that's going to be the run, so this would be 2 over 1 with a plus or minus. Okay, do you see how that all relates? We graphed it and looked at the graph to come up with the equation for the asymptotes, but you could just as well look at the equation. In fact, I would advise just looking at the equation because sometimes this gets to be a bit of a mess. Okay, are there any questions? Okay, opens up and down. Okay, so again, I'm going to do this in blue. That means it's going to touch right here and it's going to touch right here. It's going to run along here, hit that vertex, curve around really quickly. Same thing on the bottom part. Okay, lots of symmetry here. Mine doesn't really look like it, but there is. Okay, we could label the center. So the center here is 0, 0. This point right here is one vertex. And this point right here is another vertex. So we were at 0 and we went straight up. So this is going to be 0, 2, and this is going to be 0, -2. And then the only other thing that we need to find is the foci. Okay? The foci are going to be inside the curved part of the conic section. So there's going to be one in here and one in here. How do we figure out how far we go from the center to get to the focus? Add those together. So this is going to be 4 plus 1, that's c squared. C is going to equal the square root of 5. Square root of 5 is just a little bit more than 2. So I'm going to go up a little bit more than 2. Hardly even looks like it's off the graph there. So that focus is, go ahead and label that. Go down a little bit more than a little bit more than 2. So that's going to be the other focus. Go ahead and label that. Didn't go right or left, just went up, so this is going to be 0 radical 5, and this is going to be 0 negative radical 5. Any questions there? Sure? Okay. Would you do the next one? Check with your neighbor before you start graphing. Get it in the graph-friendly form, complete the square. Don't start graphing until you check with your neighbor. Make sure you both got the same thing. Charles, what do we do first here?
You put the x's together.
Put the x's together, so I'm going to write x squared minus 4x. And I put the y's together, so minus y squared minus 4y. And then move the 9 over. Okay, that's the first step. Okay, Alex, what's next?
Then you complete the square. So
Okay.
You find half of 4, -4, which is 2. And you circle that, and then you square it, which is plus 4. And then on y, well, you can distribute out the -1.
Okay, you actually have to factor out the -1. So here's what you should do. When you're rewriting this, when you're collecting these together, if you can factor out a negative or a number, that would be a good idea to do right there. So on this one, I would factor out the negative. That would make this a positive 4, and then have the set of parentheses there. Now we can take half that middle coefficient, so that's going to be 2. Square that, that's 4. Now, whenever we put these numbers inside parentheses, I always said take a line and draw a line from the number out front to that number right there. Okay, what do I get when I multiply the number out front with the 4? I get a 4, because really it's a 1, right? So I added 4 on this side. What do I do on this side? Add 4. So I'm going to add 4 over there. Okay, on this one, when I draw this line, negative times positive 4, that's going to be negative 4. What do I do on the other side? Subtract 4. So I've made my perfect squares. I've made this, so this is going to be x minus 2 quantity squared. This is going to be minus y plus 2 quantity squared, and over on this side it's a 9. What do we do next, Caitlin? Divide by 9. So if I divide everything by 9, this is what I get. Let's see. So I've got x minus 2 quantity squared over 9 minus y plus 2 quantity squared over 9 equals 1. Now, some people will look at this and they'll say, wait a minute, that's weird. They're both the same number. Does that matter? Not a bit. What does that make our fundamental rectangle, John? It makes it a square. That doesn't matter. Square's still a rectangle, so let's go ahead and graph that. Now, okay, if you were me on the test, I'd probably want to go ahead and figure out the asymptotes, because those tend to, again, be something people struggle with. So we could write those down really easily. This is going to be y plus 2 equals, let's see here. Number underneath the y is a 9. Square root of that is 3. That's the rise. Number underneath the x, that's a 9. Square root of that is 3. That's the run. 3 over 3 is 1. So I'm going to write plus or minus 1, x minus 2. Those are the asymptotes right there. Okay, now let's see if it actually works out that way. Where's the center? Okay, make sure you find the x. Make sure you found the right one. It is 2 comma negative 2. So the center is at 2, negative 2. Everybody with me? Okay, Nathan, how far do we go in each direction, each x direction, to get the fundamental rectangle? Square root of 9?
Oh, yeah.
So we're going to go 3. 1, 2, 3, so we'll be right here. And 1, 2, 3, so we'll be right here. And Kang, how far do we go in the y direction to make the fundamental rectangle? If this is the center, we go 3 units. 1, 2, 3, and we go 1, 2, 3. So we're right here. So here's our fundamental rectangle, which on this one happens to be a square. We'll draw in the asymptotes. So hyperbolas do take some time, especially if you've got to complete the square. That's what it looks like. Okay, let's just confirm the asymptotes. The center is at 2 comma negative 2. So if it's y minus k, that would be y minus a minus 2, or y minus y1 if you want to think of it that way. And this would be x minus x1. There's x1, so this is going to be x minus 2. I'd go up 3, and I'd go over 3. So that would be a rise of 3, a run of 3, so that means our slope's going to be 1 for the one going up. It's going to be negative 1 for the one going down, because I could go to the right 3 and then down 3 for the run if I wanted. Okay? Any questions there? Okay, so we got the asymptote right, we got the fundamental rectangle there, we've got the center, all that sort of stuff. Which way does this open?
Right.
Opens right and left. Opens right and left. So that means this point that we drew right here for the end point, or the side of the fundamental rectangle, that's going to be a vertex, and that's going to be a vertex. So I've got my center. I'm going to go ahead and label the vertices before I start graphing this. We were at 2. I'm going to go over 3 more, so that's going to put me at 5 comma negative 2. I was at 2, I'm going to back up 3. That's going to put me with a vertex at negative 1 comma negative 2. So there's the vertices. And then let's go ahead and sketch this. So kind of straighten out, and then we'll bend around, curve around, and then straighten out, go right along that asymptote. Yeah?
Sorry, can you go back a little bit? How did you get y plus 2 instead of y minus 2?
Because it's going to be, remember, it's y minus y1.
Okay.
Whatever the y coordinate is that the point goes through.
No, not on that equation, on the equation like for the
Oh, this guy right here? Because when we factor out the negative, this becomes a y squared plus 4y. So then when we take half of that, that's half of positive 4 is positive 2. Is that good? Questions there? Okay, so now we'll finish graphing the other side. Hug along that asymptote, come around here, hit that point right there, keep curving around, and then straighten out along that asymptote. We've got that graph now. The only thing left, we have the entire hyperbola, center, vertices, asymptotes, rectangle. What do we need now? Focus. Okay, foci. There are two of them. I add the two of these together to make sure I'm outside either side of the box. It's always going to be inside the curved part of the conic section. In this case, it's going to be along the transverse axis, the one that cuts across both of them. I add the two of those together, so that's 9 plus 9 equals c squared. That's going to be 18 equals c squared. So c equals the square root of 18, or that would be 3 radical 2. Now, the square root of 18 is a little bit more than 4, a little more than 4, okay? Because 16 is a perfect square of 4, so 18 is a little bit more than 16. We're going to have a square root that's a little bit more than 4. So I'm going to go a little bit more than 1, 2, 3, 4. So we're going to be about right there. There's one focus. 1, 2, 3, 4. A little bit more than 4. There's another focus. And then I just want to write down where they are. Now, notice that all of these are along the same horizontal line. That means they all have the same which coordinate? Same y coordinate. Thank you, Charles. So it's going to be -2 for a y coordinate. All I have to do is figure out, how do I represent the x coordinate? From the center, which is at 2, -2. We already got the -2 taken care of, but I start at 2. I'm going to go forward 3 radical 2. So start at 2 plus 3 radical 2. What's this one going to be? 2 minus 3 radical 2. Okay, see all those numbers? They're kind of like they're conjugates of each other. Okay. Any questions? Okay. Harder than a parabola? I think so. Harder than an ellipse? A little bit harder than an ellipse, only because there's more information to keep track of. The only real extra thing is we've got some asymptotes to graph, and instead of being a parabola, or excuse me, an ellipse that's inside the box, it's a hyperbola that's outside the box. Other than that, it's pretty much the same. Okay, so maybe another 20-25% of work above and beyond what an ellipse is. Okay, are there any questions so far? Yeah. Is there food in there? Go ahead. You're going to have to answer the questions when we get back. So we've done some that open left and right and some that open up and down. Pretty even balance here. Now we're going to get to the problems where they give us information about the hyperbola and we have to come up with the equation. So my first question is, do you have to graph the hyperbola in order to solve these problems? You don't have to, but it's pretty darn helpful to do it that way. Okay? You don't have to, but it's pretty helpful. So center is at 0, 0. Okay, that's good news because that means we're going to have a perfect square of x, perfect square of y, just x squared and y squared. So the center is here. It's got a focus at -3, 0. So -3, 1, 2, 3. There's a focus. And a vertex at 2, 0. There's a vertex. Now, take a good look at that. That right there is enough information to figure out most of the equation. Gosh, maybe it's all the equation. Okay, if the center's here and we've got a vertex here, which way does it have to open? Right and left. Which variable has to be positive? X has to be positive. So we know we've got an x squared, we know we've got a y squared, we know this one's going to be positive, we know that one's going to be negative, and it's got to equal 1. Remember doing this with ellipses? If you know that much information, you can fill in everything except for what goes underneath the x and what goes underneath the y. So now let's take a look at this. If there's a vertex here, 2 sides on the right side of the center, there'd have to be a vertex over here, 2 units on the left side of the center, and there'd have to be a focus over here as well. From the center, I went how far to the right and the left? Square root of 4. So I take that 2, square it, I get 4. Where do I put the 4? Underneath the x. Now, how do I figure this one out? A squared plus b squared equals c squared. Remember, we add those together. So I know what a is. I know that's a 4. I don't know the b, but I do know how big is c. How far did we go from the center to get to the focus? I went 3, so this is going to be 9. So I move this over. And again, here's the cool part about this. Even though this would be an ugly number to find this, I don't care that b is radical 5. I don't even need that because they didn't say graph it. The number underneath here is b squared. This one's a squared. That one's got to be b squared. So this is just a 5. That's the answer right there. Looked at the information, thought about what it means about the equation, and then figured out the missing pieces. That's it. That's all there is to it. Just come up with the equation. Okay, any questions? Okay, this next one's pretty interesting. You ready? Okay, I'm going to give you a minute or two to figure this out. Do the same thing. There's some key information hidden right in here in that equation. Okay, think about it, see if you can figure it out. If you can, don't share it yet. There's a lot you can tell just by looking on this one. It's not easy, but you can figure it out. Anybody got it figured out? One hand. 1.5. Josh, what do you think the equation is? X squared minus y squared over 3 equals 1. Let's check and see. A couple things you'd notice. If we sketch these, 0, plus, and minus 2, I've got a focus here and I've got a focus here. Which variable's positive? Y's got to be positive because it's going to open up and down. Okay, if those foci are stacked on top of each other, one branch has got to open up, the other branch has got to open down. So y is going to be positive. Okay, since the center is 0, 0, that's right in the middle of the two foci, that means we're going to have a y squared and a minus x squared. Okay, you can also look at this right here. Notice there's no number with the y, so that means k has to be 0. There's no number with the x. That means h has to be 0. So this is going to be y squared over something minus x squared over something equals 1. Okay, now Josh said it was a 3 underneath the x. Is that what you said? Okay, let's check and see. Here's the hidden information right here. Plus or minus. Okay, this one happened to be minus. Okay, it goes like this. That means the slope is 1. Here's the tough thing about that. We did one up here where the slope ended up being 1. But the C was, or sorry, the A and the B, they were both 3s. They weren't both 1s, they were both 3s. So what this tells us, this is kind of hidden information. It doesn't mean that A is 1 and B is 1. What it means is, however far you went up, That's how far you went to the right. They both had to be the same. So that means a squared plus b squared equals c squared. That means these two are the same. These numbers have to be the same. So that means we could do a squared plus b squared equals, sorry, let's make them both a squared since they're both going to be the same. Okay, how far is it from here to here? 2. Square that, 4. So this is 2a squared has to equal 4. That means a squared is 2. If a squared is 2, what's b squared? 2. That's the equation. Now here's the awesome part. Okay, everybody good there? Here's the great part. On this particular problem, if we were to actually graph this, how far would we go in the y direction? Square root of 2. I'd go about 1.4. And how far would I go in the y direction? Or sorry, in the x direction? Square root of 2. So 1.4. So I'd be about right here. That's what the fundamental rectangle would look like on this one. Okay? You'd have a rise of the square root of 2 and a run of the square root of 2. Okay, there's your 1. Okay? Any questions there? Okay. What shape is this? It looks like a pretty simple graph. What shape is it? It is a hyperbola. Kind of looks like a circle though, doesn't it? What's underneath each one of these? A 1. So the center is at -2, +1. -2, +1. How far are we going to go in each direction for the fundamental rectangle? 1. It's going to be a fundamental square. This is what it looks like. Everybody watching? Here are the asymptotes. Grab the expression with the y minus 1. Grab the expression with the x plus 2. Number underneath the y, take the square root, that's a 1. Number underneath the x, take the square root, that's a 1. So what do I put in front here? Plus and minus 1. Okay, there are the asymptotes. And then Samantha, which way does this open? Up and down or right and left?
Up and down.
Samantha says up and down. Alyssa, is that right? Okay, why not? Okay, the x is positive. We tell by looking at the positive variable. So we've got this point on the fundamental rectangle. We're going to come down and hit that and go like this, sort of. Okay, and go like this. Okay, on this one, the points are easy to find and they're easy to label. The center is -2, 1. That vertex there and that vertex there, we got to get both of those. So this one is, we went forward 1, so that's going to be -1, 1. We went back 1, so that's going to be -3, 1. And then we're going to have a focus in here somewhere. So let's figure out where the focus is. Take the two of those, add them together. So 1 plus 1 equals c squared. So c equals the square root of 2. So we go a little bit more than 1 in each of those directions. So I'm going to have a focus about right there and a focus about right there. Again, if the picture doesn't look very good, but you label it correctly, that's the important part. Charles, which coordinate do we know on both of these? The y coordinate. Y coordinate's always 1 because it's on that transverse axis. They're all 1 unit above the x-axis. And I went forward radical 2. I was at, forward radical 2. So I was at -2. I add radical 2. And I was at -2. I subtract radical 2. Okay. Any questions? Yeah.
Don't we need to label the transverse axis and the
You don't have to. Okay, there are parts that help you figure out where to put stuff. Like these are all on the transverse axis, so they all have a y coordinate of 1 because it's a horizontal transverse axis. If you want to label it, you can. Okay. All right. Go ahead and do B. Okay, let's see how we're doing. First thing we'd want to do is divide everything by 4. So here's the equation we're working with. We're working with y minus 3 quantity squared over 4 minus x minus 1 quantity squared over 1 equals 1. Okay, I'm going to go ahead and write the equation for the asymptotes. I'm going to write y minus 3 equals, and then x minus 1 here, and all I need is the number that goes in front here. It's going to have a plus or a minus. Where do I find the rise? Underneath the y. What's the square root? 2. Where do I find the run? Underneath the run is underneath the x. That's a 1. Okay? So this is y minus 3 plus or equals plus or minus 2x minus 1. There's an equation for the asymptotes. That's both of them. Okay? The center on this one is, careful, where is it? 1, 3. Okay, don't say it's at 3, 1. Don't mix up the x's and the y's. The k is with the y, h is with the x. So we're going to go to 1, 3. So we're right here. How far do we go in the y direction? 1, 2. 1, 2. It's going to open in the y direction, up and down, because that's positive. Then I go 1 unit in each of the directions there, so it looks like this. There's our fundamental rectangle. There's our asymptote here, and here's our asymptote here. And we can sketch the graph. The graph's going to look something like this. Going to come down, touch that fundamental rectangle right there, and then go like this. Come up, touch that fundamental rectangle right there, and go down. If the center was at 1, 3, and I went up 2, then the vertex would be at 1, 5, and this vertex would be at 1, 1. All I need now is the foci, right? I've got everything else. So I take those two numbers and add them together. 4 plus 1 is 5. So C equals the square root of 5. So I'm going to put a focus right here, and I'm going to put a focus right here. And that's going to be at, they all have the same x-coordinate. I just went up from the center radical 5, so that's going to be 3 plus radical 5. And this is going to be 3 minus radical 5. And that's the right graph. Any questions? Okay, real quick, we'll probably go over by just a couple minutes, but I'll let you out early tomorrow. I've got 3 written down here, 24 is right here, and I actually have 29 right there. Okay, so I want to make sure we can do this. Look in your book. These are just matching. Okay, this one has a center at 0, 0, and it opens to the right and to the left. Which variable is positive? X. So it's going to be x squared minus y squared equals 1. How far did we go in the x direction to get to the vertex? Okay, yeah, so we went 2 units, so we square that. So underneath the x is going to be a 4. Find one, match it up with that one. It would be the only one that's positive with the x squared, plain old x squared with a 4 underneath it, okay? And you can take the time to figure out what the other one is, but it's just matching. Let's take a look at this. These are all 1. So you go up 1 and over 1. Okay, it opens up and down. Which variable is positive? Y. So this is going to be a y squared. Again, the center's at 0. An x squared, and this is going to be a 1. And then we just need to know the number right here. We went up 1. What goes underneath the y? 1 squared. Okay? We went over 1. They drew the entire picture for you. You don't have to use any equations to figure it out. What goes underneath the x? A 1. That's it. This is just y squared minus x squared equals 1. That's the equation. Okay? Some of them are that simple. You do have to think about them, but some of them really are a piece of cake. Are there any questions on either of those two? Okay. Then again, these are typically the type of problems that people struggle with. They're when they give you information about the hyperbola and you have to come up with the equation. These are just, well, we already did a couple like this. These are just a tad more difficult. Okay. If we have time, we'll do this one right here. I just want to point this out. This would have come from the y. That would have to do with the rise, and that would have come from the x. Okay, so when you put all of this information, you can probably figure that out. By the way, if that's y plus 1, wouldn't that be the y minus k? And wouldn't this be the x minus h? Okay, so hopefully that's not too bad. Center is at -3, -4. Don't have to graph it, but that's probably going to be helpful. Focus at -3, -8. That's -8. That's -4. And it has a vertex at -3, -2. So there's a vertex. There's the center. There's a focus. And this is -2. So if this is the center and it's got a vertex up here, it would have to have a vertex down here. And it would have to have a focus up here. So it's got to go like this. Which variable is positive? Y. Y is positive. So would it just be this, like we've been writing? No, because that has a center at the origin. Okay, this has a center right here. There's the H, there's the K. Let's be careful with this. I'm going to write down Y plus 4. 4 minus x plus 3 equals 1. Then I just need the number underneath. Okay. From the center, I go up 2 and down 2. That's a 4. How do I figure this one out? A squared plus b squared equals c squared. It's just like the Pythagorean theorem, and I know this one. 4 plus b squared equals, well, let's see, c squared. How far did I go from the center to get to the vertex? If I started at -4 and went down to -8, that would be 4. So this is going to be 4 squared, so this is going to be 16. So that means b squared is going to be, again, the cool part is, do the subtraction, you get a 12, slap that number underneath there, you're done. That's it. Okay? Okay, real quickly. Vertices are here. Again, what does this tell you? This tells you h and k. We already know what the center is. The center is going to be at 1, -1. 1, -1 right here. Vertices at -1, -1. So here's the center. There's a vertex and 3, -1. Which way does it open? Left and right. There's a vertex and there's a vertex. Which variable's got to be positive? X. Grab this. X minus 1 quantity squared. Y plus 1 quantity squared equals 1. And again, just the numbers underneath. Which of the two can you figure out immediately? From the center over this direction I went 2. So that goes underneath, because I'm going in a horizontal direction, square that, that goes underneath the x. And then you can find this one, what is it? Very good, under the asymptote. Okay, take a look. This is 2 units, that matches up perfectly. This must be the square root of b. So what must this be? Must be a 9. See how using your head can put this all together? Okay, if you need to watch the video again, please do. Please get on this. This is not going to go away, and your grade's going to suffer if you don't get this figured out. Come and see me if you've got questions.